Alright, it's Devlog Thursday, at least when I recorded this. I don't know when this is going up. I mean, there's a possibility that it will be today, but I don't know. Anyway, the reason I missed the last Devlog Thursday was because schoolwork got in the way, stuff that I really needed to finish, so I had to focus all of my attention on that. But I have gotten some work done on the new Xe2020B, and it's mostly finished, but there are some problems that I'm going to get to. I mean, currently you can see there's a lot going on here. And really the only things that are crucial to the function of this computer itself are, of course, the CPU right here, the block copy unit right here, the BIOS, this is a little junction box or whatever, interface router, I guess, that controls whether the block copy unit or the BIOS is controlling the terminal right here. And we've got the ROM and the RAM. Everything else is for debugging. And the reason that there needs to be debugging is because, well, there's a bug, obviously. And the various things we have are this stack monitor. This is supposed to show me what's actually in the stack, which is important because that seems to be where the problem is coming from. Then I've got this, which is technically also a stack because of the way that it stores the data that I put into it. And the data that I put into it is instruction opcodes. And so basically the instruction opcodes are read from bottom to top and they move downward, well, when it's first filling up, and then it shifts everything upward as each new opcode is inserted. And that basically gives me an idea of what instructions are executing. And what I can do is I can use that as a reference. If I go in here, this is the assembly code for the Tic-Tac-Toe game. Oh yeah, by the way, this is the Tic-Tac-Toe game that I'm debugging. I'm porting it to the 16-bit CPU at the same time that I'm debugging it, because it's not working immediately. I mean, that's to be expected, I guess. But anyway, my point is, I can reference these instructions that are being executed right here and match them up to a sequence of instructions from the assembly code, so I know where exactly in the code it is, and I can see whether or not it's doing what it's supposed to be doing. Now, this is probably going to be a very cut down video, because what I plan to do is kind of like a game dev session, like the one that I did for Adventure World many months ago, except it's going to be cut down. I've actually tried to do some game dev sessions since then, but they either just didn't go well, or I lost all my editing progress. Like that one time. We don't talk about that time. Anyway, so yeah, I'm going to do a Logisim debugging session. And I'll just go ahead and start by showing you what the goal is, and what the problem is. So if I do Control-K to start the ticks, actually let me make sure that we're running at the fastest possible speed. And we are. So if I use Control-K, you can see that the text comes up really fast. And why is there... I think that's a grave accent that's right there. Did that accidentally get typed in and I didn't see it? I don't know. It's important that I know. So if I do that... Okay, it must have been something that I must have had on the keyboard. I'll have to look at that. But anyway, you saw that the text came up really fast. And the main reasons for the speed boost is, one, that the Xe2020B is just generally faster than its 8-bit counterpart. And also, it has a separate block copy unit, because that's something that I couldn't exactly be bothered to integrate into the CPU itself. But I made sure that the CPU would be extremely compatible with coprocessors, which is what the block copy unit is. It's a coprocessor that implements exactly what it sounds like it implements. Block copies, which is copying blocks of data from one place to another. And the two ways it can copy data is it can just copy a specified amount of data from one place to another, or it can do what's called a print. And what that is basically, it prints to the terminal. You specify the starting location of a string, and it's a null terminated string, which means the way that it knows where the end of the string is that there's a null character at the end, which is basically just 0 in binary. If it were to be printed to the screen, you wouldn't see it. because the screen knows not to actually print a null character. But the reason that null character is there is so that the block copy knows when to stop, and you don't have to specify the number of words to copy. And by words, I mean groupings of 2 bytes, because the word size for a 16-bit processor is, of course, 16 bits. And I know words are also something that are things that are in strings, but I'm just trying to clear up that confusion. Anyway, let's just get to the matter at hand. It looks good so far, and if I go ahead and type in TL, it'll put something there, and then, yeah, it does that. It prints new lines for all of eternity. It's not supposed to do that. That's the problem. So what my goal is to figure out why it does that. That's going to be pretty important. So, I guess I'll start by, well, starting the program up. And T, L. Alright, so it's currently in the process of drawing right now. So if I go ahead and just look at these instructions, we see a 1B right there, and I think that's a jump to subroutine instruction. So that's good to know. And 1C is return from subroutine instruction. So what we know is that this code right here, this 222201, is just a continuous string of code. So we're in the drawing routine, so that gives us a hint of where to look. I should just close these. I don't need this open, and I don't need this open. So the drawing routine is called draw layout. You can see this is where, this is the line that gets called right after it decodes the text you put in into a location to put the X. And also after putting that X in memory. And so draw layout is where it jumps to, so I need to find previous, because the next will be the call from place O. Yeah, I know. Okay, here we are. There's 2 print instructions, which correspond to this right here. So we did print, and then load X. And that was that. And then we are currently, right here, we're jumping to draw square again. And I should probably turn down the tick speed to like 64. That's a good amount, I think. Alright, so now it's about to draw a vertical bar. Okay, that's the code. That right there is probably the code for drawing the last vertical bar. That's not the assembly code. This is the assembly code. So I'm guessing what we are printing, or what instructions we are doing, is probably this and this and this. I think these are like the bottom 3 instructions that we're probably seeing. So if I do that again, 1B, 02, 17, 1A. So as soon as we see a 1C, or okay, yeah, there's another subroutine call within the draw square subroutine. In this case, probably to the draw empty subroutine, and then 22, 1C. Okay, so that first 1C, that's still not the assembly code, would be the return that is present inside the draw empty, and the second would be the return that is present inside draw square, which means that's not Logisim, which means the next instruction we should probably see is a 22, or print. Yep, there it is. There's the print instruction right there. Now what we know is that, okay, we're only 1 subroutine deep right now. I'm fairly certain. So, okay, here's what we've figured out. The return address that is generated by this particular subroutine call is getting placed in this position on the stack, which it should not be getting placed there. It should actually be getting placed here, and this should probably be here, and this should probably be here. So something's wrong. So now our goal is to figure out why that's happening. So what we need to find out is why is the stack pointer would have to be 0 right now for that to happen, which it should be 1. Right, okay, so it's 0 right now. Yeah, it should have incremented, but it didn't, clearly. Okay, so now we have a little bit more of an idea of what the problem is. Whenever the stack pointer goes to 0 at that point, it doesn't actually increment. And so it seems like the bulk of what's causing the problems is allowing the stack pointer location, or the stack location of 0 to be usable. Because the way that a push instruction works, is that it increments the stack pointer and then it writes to the stack. But if the stack is empty, then it shouldn't actually increment the stack pointer, because we need to be able to use the very bottom of the stack, that very bottom entry, because that's still a stack position and it needs to be used. So there are exceptions to when incrementing or decrementing the stack pointer should work or not, which is what's causing these problems. I mean, I could make it to where the bottom address is just not usable, but I don't really want to do that. The way that I solved it in the previous CPU is that the stack would technically start at address FF. Well, stack pointer FF. Location of the stack was actually really high up in RAM. But anyway, and then there would be no exceptions to when it could increment or decrement the pointer. I think what I'm going to do is I'm going to take this circuitry right here. I'm going to move it over here, or somewhere where it's out of the way. And then what I'm going to do is I'm going to delete this, and that, and connect these wires, and there. Now the very bottom of the stack, at stack pointer address 0, is unusable. But in theory, it should fix the problem. It's just that you can't use that position in the stack. Actually, it's technically a 9-bit stack pointer, so that I could detect underflows and overflows much easier. But I could do a hybrid of that. So what I'm going to do is I'm going to select all of this, I'm going to move it over, and also up one, because of what I'm about to add. I'm going to add an 8, no, it's actually going to be a 9-bit subtractor. Oh, and also the SP thing is probably going to have to go right here, actually. Maybe make it point south. Yeah, like that. And then we'll be subtracting 1 from it. So let's make a 9-bit constant. Set it to 1. That should be north, right? Yeah. And connect it to there. Now, when it first increments the stack pointer, it'll actually be pointing at address 0, which means the stack overflow should occur at 101. And an underflow at 1FF. Yeah, that should honestly solve the problem, which means... Yeah, I don't want to go back to this circuitry. The circuitry never worked. So let's just get rid of it. Let's make this concrete. Yeah. I like that. I think that's what we're going to do. This should do it. Let's save it. Let's save the CPU. that's not what I want. Okay, there we go. Reload the CPU circuit. And, I guess let's try it. Wait, hold on. Make sure that the changes have taken place. Yep. I'm nervous. Okay. Top left. Wow. Okay. It looks like it worked, but there's a backslash in my string. I'm gonna wait for the Unity project to open, or to come back up, and I'll get to show you the assembler. What? Oh. Cool. Alright, we're here, and this is what it looks like. This is the file menu where you select an assembly file to open. And I'll pick this one. This is the right file, right? Let me check the file name. Yeah. Click that. And you can see that there's syntax highlighting. You cannot actually edit the code from here. I mean, I tried that one time. In fact, I tried that with the very first version of the assembler, but it was a little bit finicky because since there's formatting in the text, whenever certain formatting tags, or just whenever formatting tags go away because of a change of syntax, it moves your cursor because there's a different number of characters in the text, and that was a little bit weird, a little bit frustrating. I was going to say, is frustrating the right word? Yeah, it was a little bit frustrating. And I was looking into the TextMesh Pro documentation, and I think there's definitely a way around that, but I think there were some other problems that I just didn't quite like. But I just like this anyway. I like to be able to look at the code. And here are the strings, and this font is called Consolas, and I started using it in the documentation for code, because I remembered there was a font that, I'm like, hey, that really looks like code, like those fonts that they use for code, and I really like it. So I can go ahead and clear the contents of this ROM, can edit them, and paste in my Tic-Tac-Toe code, and I can start it up. Wait, is this still open? Yeah, I don't want to have that open while running Logisim. So if I hit Control-K, here we are. Extremely fast Tic-Tac-Toe. So let's put something in the top left. It's good. Put something in the top middle. Wait. It's taking input, isn't it? It is. Oh. It's just not allowing me to place anything anywhere. Okay. Huh. Wait a minute. Insert player 1 char 2. Wait, what is that called? Insert player 2 char 1. Okay, where's insert player 1 char 1? I seem to remember I messed up. Yeah, it's supposed to store that in the row. And it never did it? Okay. Okay, insert player 1 char 2. I'm guessing that has to store in the column. Yep. So that was the problem. Just something that I fixed for player 1 and didn't think to fix for player 2 at the time. That was a long time ago that I had to fix that. Well, maybe a week by now, probably. I don't know. Anyway, no, more than a week, probably. That's not important. What's important is that I know what the problem is. So now I can go into this, and I can reassemble the code, and it should work. Clear the contents. Yes, I'm sure. Paste it, and full speed, and go. All right. Top left, please. Thank you. Top middle, please. No, not quite. What if I try to go there? No. What if oh wait, no, top right. Interesting. What if I try to go there again? Nope. Aha! Okay. So apparently writing an O doesn't actually write an O, it just writes nothing. Okay. Why might that be? Oh! Because it's a load X instead of a load Y. If it's doing load X, then it's going to replace... Yeah, because in the X register is the value that it's checking against. Okay, so it was just a simple, yeah, that's why. Okay. Alright, let's assemble. Completed successfully. That's always nice to hear. Go ahead and clear this. We don't need the old code. We need the new code. Like that. There we go. And full speed ahead. Top left. Cool. So if I put an O, will it actually be an O? It will. Nice. Now let's put something in the middle. Alright. Now. Okay. What? Huh, okay. Better look at that later. Okay, player 2's turn, so yeah. Player 2 does not have a very good strategy, so yeah. Now, if I place that, it crashes because it's actually supposed to do that. Wait, where is it in memory? Isn't it just supposed to be spinning? Let's check. Okay, what does it do when it's time to... Oh no, I didn't get rid of the label, so... Okay, yeah, it is jumping to this particular location, isn't it? Let's find out. Yeah, it's still gonna jump there, but there's just nothing there. Okay, so it works now. I mean, it sure doesn't look like it works, but that's because I actually haven't finished converting the code. But, yeah, it works. Thanks for watching. Some music. I have some music that I need to upload soon. Well, I actually need to make the videos, but the music is done, and I have some music to upload soon. So, look forward to that. Thanks for watching, and bye!